All right, guys. So we're going to go back. We're going to pick up where we left off yesterday. We are looking to uh, add some more functionality. If you remember, we added a move and slide. And currently, although taken some things away, which may cause our game to crash here. Let's see. Direction, time, speed. Why is that a problem? Well, because I took the direction vector away. Um, so let me just show you what I've added. I've added a new thing that we haven't talked about before, and that's a constant. A constant is something similar to a variable in that Godot can refer to it, but the constant doesn't change. It's going to stay the same. And the convention for constants in Godot is to use all caps when naming it. So pos DIRs just means possible directions. These are the directions that I want my clown to be able to move in. And what I'm going to do is in my ready function, I am going to choose one of those things randomly. Now you'll notice these hard brackets around the four major directions, excuse me, up, down, left, and right. And what I'm going to do is I'm going to have Godot choose one of those by random. And here's how I'm going to do it. I'm going to say that direction, which by the way, still has to be declared as a variable. But right now, direction is a variable, but it's not been given any value. So direction is going to equal, and now I'm going to use a random function of Godot. We've done a little bit of randomness in our game maker, but here we're going to use it to choose one of those random directions. So first I have to tell it where to find those directions. So it's going to look for the possible direction array. So an array is a collection of variables that have been all organized. And it's one thing you should know about it is arrays are referred to, or these values are referred to by using a number inside of brackets. And they are numbered 1, 0, the first space is 0, 1, 2, 3, and so on. So if I said I wanted my direction to be the first value in this array, then my clown should move up. Let's find out if that's in fact what happens. And my clown does move up. 0 is the first spot in this array. If I wanted them to move left, then I would have to go 0, 1, 2. So if I put 2 here, my clown should move left. And he does. Now I want it to be random, so I'm going to actually use a function called randi, and then parentheses with a percentage, and then the value after that is how many possible outcomes I want there to be. So if there's 1, 2, 3, 4, there are 4 possible outcomes, and I'm going to put 4. Now, randi does count 0 as the first one. So it's actually going to generate a number between 0 and 3. So there's 4 outcomes, but 0 happens to be one of them. If I needed the number to say be between 1 and 4, then I'd have to add 1 to make sure that whatever this was would be between 1 and 4. But I don't need that. I want it to be between 0 and 3, 4 possible outcomes. And to make sure that it's truly random, I'm going to randomize. And let's see if I can get my clown moving in the different directions in the ready statement, which is very, very similar to a create event in GameMaker. So let's see what happens. Okay, he moves left, restart the game. He moves right. Let's see if we can get an up and a down. Excuse me. Does not seem to want. There, he finally moves up. And then if we can get it down, that'll prove. Okay, so we do have those 4 directions. Now, I also want to have diagonals because I want this game to be as much like the Game Maker game as I can. So I'm going to add vector to -1, -1, which would be up and to the left. And I got to move my picture here, always in the way. Vector to +1, +1. So that would be right and down. So I got 2 more directions to do. Don't know what happened there. Enter, tab, vector 2. Let's see, I didn't use -1, +1, and I didn't use +1, -1. So that should be all of them. So -1 would be to the left in a positive direction, which would be down. And then -1 would be to the right. And I don't even know if this is showing up on the camera right. And negative would be up. So now I can move in 8 different directions, including the diagonals. There is something funny about diagonals, though, and it has to do with the Pythagorean theorem. If I'm moving 1 unit to the right, I would be moving 1. If I was moving 1 unit up or down, I'd only be moving 1 unit, the equivalent of 1 unit. However, when you have a diagonal, so when it's moving in this direction, so let's say it was moving in +1, +1. If you have studied Pythagorean theorem, you know that A and B might be 1 length, but C is a little bit longer, and that's that whole a squared plus b squared equals c squared. So you will find that when you have a diagonal direction, oftentimes your object seems to be moving faster than when it's just moving left and right. And that's because of Pythagorean theorem and some math, which you probably thought you'd never need to know, but in game design you do. So I'll have to keep in mind that diagonals can oftentimes result in a faster speed, and there's a built-in function of Godot to handle that. Now, I've added more directions, and I guess I could simply add this number up. But what if I want to add more later? Well, there's a way to do that. I'm going to say that instead of 4, I want to find the size of my array. So POSSDIR dot size. And now, anytime I change my array to a bigger or smaller number, this will automatically adjust. Let's make sure I did it right. I didn't. And why is that? I must have made a typo somewhere. Oh, here, that's not a comma. All right, let's try it again. Okay, not a diagonal yet. And now we do have a diagonal. Now, one thing you're going to notice is did you notice when he collided here and then he slid along the surface? That's one of the features of move and slide. That's the slide part of move and slide. And it works really well for platformers when you are jumping and then landing on the ground and you want your player to be able to continue to move instead of getting stuck in the ground. Not really what I was looking for as an effect, but that is one advantage of move and slide. One cool thing it does. Another thing that move and slide does is it allows us to use a couple built-in if statements. It can check on some things, and you'll notice that I've added a second argument here, vector 2, 0, -1, which if you don't remember is 0 left to right, but negative on the y, which is moving up. So I have indicated an up statement, and that allows me to then do this. So if you put an up and a move and slide, it sort of tells Godot to handle this space as if it was you were in a side scrolling platformer. So that means that this is going to be considered the ceiling, this is going to be considered 2 walls, and this is going to be considered the floor. And so because of that, because we've declared the up, and now Godot understands how our space in the world works, we can add a couple of things to do where it can deal with those collisions. So if is on wall, then what we want to do is we want the direction X to be the opposite sign. So if it was moving in a positive direction, left to right, when it hits a wall, it's going to change that positive to a negative. And if we were moving in a negative direction, it's going to change that into a positive. Then I can say LF, which basically is short for else if, is on ceiling, which I spelled wrong, or is, I forgot the parentheses, or is on floor. We're not going to change the X, we're going to change the Y direction and change the sign of that. So if it was going in a negative direction up, now it's moving in a positive direction down. Let's see, I feel like there's something I did want to add. Oh yeah, so anytime we are dealing with potential diagonals, if you want a diagonal to have the same length as just straight up and down or to the left, one of the things that you can do is go direction dot normalized. And normalized will change something that's a diagonal and give it a length of 1 so that he will move at the same speed going left to right as he will diagonally. You'll see this a lot in a lot of Godot tutorials. So now let's see if our clown, instead of sliding along a surface, will just change its direction as if bouncing. And that looks pretty good. So one thing you'll notice, however, and we'll see it really here as the clown changes directions instead of sliding on that surface, is that our clown doesn't rotate. So we're going to create our very own function. So far we've used built-in ones. We've used the ready function and we've used the physics process function, all built in. But we can program our own function. So we're going to say rotate clown. And what we're going to do is say rotation equals direction angle. And this will rotate our clown. So where do we want to have that happen? Well, after he chooses his first direction. By the way, this is a lot to type. So I'm actually going to make another function, which is choose direction. What will happen is instead of typing this out every time we want the clown to choose a new direction, all we have to do is call that function choose direction. And when the name of this function is called in any of the other functions, it'll jump and do this thing, which when you have a function that has a ton of instruction in it, saves you a lot of time. So we want our clown to choose direction. We also want him to rotate. So we want to actually probably do that every time we change direction. So I don't even need that there. We're going to put it here. So when he chooses a new direction, we're going to have our clown rotate. So it looks like I forgot some colon, and let's see how that works. So now our clown should be facing the direction he's moving. He is moving at a kind of a slow speed, and we're going to fix that in a minute. He bounces. He did not rotate, so I got to remember to call that function anytime he does collide. So rotate clown. Rotate clown. And that should fix that. So facing the right direction, collides, changes direction. And now the last thing I want to do in this video is make our clown interactive, because right now we can watch him and we can make him go in different directions by restarting the game, but we can't really interact with him. So we are going to use another built-in function, and that's the input function. So anytime you're using a built-in one, typically those start with an underscore. And when you program your own, normally you can leave the underscore out. So what this is going to do is anytime the player does anything, it's going to report that an event has taken place, an input event. And so that means when I play, pay attention down here in the in this area, you'll notice that the output shows that I am moving the mouse around. If I click a button, it'll report that a mouse button was clicked. If I hit a key, it'll report a key has been struck. And so an event has registered. I don't think I could do it. You could use a screen touch depending on what you're using. So what I need to do is I need to decide what events I want to handle. What do I want the game to react to? So I'm going to say if input event mouse, and you'll see mouse button is one of those things that registered. So mouse button. So it's only going to pay attention if a mouse button has been pushed and the event is pressed. What this will do is only register when my um, my button is first pressed, and I can leave the button pressed down for an hour, and it will only register that first press. So what I'm going to do is I'm going to have it say print button pressed. And then, so one of the great things Godot has is this output section that gives you feedback and helps you debug and figure out how to make things work. GameMaker does not have that, and it is something that I find incredibly useful. So I'm going to go ahead and play my game again. I'm going to click, and you'll notice that it only registers when the button is pressed. What if I press a key on the keyboard? Well, it did actually accept that. So that was unexpected, because it should only, let me try that again. Input event mouse button. Well, that was unexpected, and I'm not entirely sure what's going on with that. It should not have registered because it wasn't an input event mouse button. So I'll have to look into that and find out why that happened. But now the next thing I need to do is make sure that this is only happening when the mouse is inside of the player. So I need to use something similar to what I did in GameMaker. If you remember, I used a variable called mouse in, and what I'm going to use is a built-in signal. Signals are sort of like events in GameMaker, or yeah, they're sort of like events in GameMaker, and there's several built-in signals that different nodes are equipped to handle. So the clown is equipped to handle, and this is some work I had done earlier and deleted. Mouse entered and mouse exited. We're going to use those. So I'm going to connect mouse entered to the clown, and I'm going to go back and do the same for mouse exited. And you'll notice that it creates two functions. So when the clown mouse on clown mouse entered, I want to make mouse in equal to true, and down here I want to make mouse in equal to false. Just like in GameMaker, when the clown leaves, when the mouse leaves the clown, we don't want mouse in to be true anymore. So then we got to add one more check. If mouse in, which is the exact same thing as typing if mouse in is equal to true. So if mouse in, then we want to print clown click. And let's see how that works. Hopefully better than my other demo. So right now I'm going to click anywhere in the room, and you can see my output doesn't report anything. However, when I click on the clown, switch back to the output, now it does detect it. But I am interested in the space key and the other keys seem to work, and I cannot explain that. Because it should only be detecting if the event is a mouse button press. So I don't know. Typically, I wouldn't expect that. So anyways, now we know that we can click the mouse. So a couple things that I want to do in this case is I want the mouse or the clown to jump to a new location. So to do that, I'm going to have I'm going to say position is going to equal a vector 2, because the position in the room needs an X and a Y. And I'm going to say, in order to avoid the clown being moved into a wall, which could potentially break the game, I'm going to have there be a 100 pixel barrier. So the minimum, I'm going to say rand range, the minimum 100. The maximum is going to be the room width, what we know from game design as room width. But I haven't defined that yet, and there are no built-in, or there are very few built-in variables. So you can see I've declared room size, but Godot doesn't quite know what room size is yet. So to find room size, I'm going to get viewport rect. Now remember, I have to declare room size as a variable to use it here. Room size, get viewport rect dot size. And what that's going to do, if I can print that, print room size, is it's going to give me a vector 2 of the size of the room. Unless, oops, I have to comment this out and then pass to prevent that from happening. You can see it gives me a vector 2, the X and the Y of the room size. So now that I know that, I can say that my position is going to jump to somewhere on the X between 100 and room size dot X minus 100. Room size dot X is 640. So that would be 540. So there's my X. And now I need to have the same thing happen on the Y, room size dot Y minus 100. And then I've got to get rid of some extra parentheses here. Let's see if that does the trick. So it's going to jump to a new position. I am going to have it choose direction, and I'm going to have it rotate the clown. And let's see if all of those things happen when I play. Only if, well, you know this is a lie. There's a mouse button pressed, and only at the moment it's pressed, and only if mouse in is true. So, okay, he's jumping. One thing that I might include is having the clown speed up. So I know in GameMaker, we've done the set variable relative. You can do the same thing here. We're going to say speed plus equals 20. And what that will do is it will take the current value of speed and add 20 to it. So let's do that. So see if our clown speeds up. Notice he seems to be traveling at the same speed, whether or not he's moving diagonally or horizontally and vertical. And that's because we normalized direction to make sure it always has a length of 1. So right now we get a clown that's starting to act a lot like he did in Catch the Clown, the Game Maker version. So we've done a lot today. We have created a constant using an array to keep track of all of our possible directions. We've had them, we've defined a room size. We can get rid of this. We've had them, we've randomized to make sure each time we play, our clown chooses a different direction. When he does choose a different direction, he rotates. We've added some features special to move and slide using if it is on wall and is on ceiling or is on floor to change his direction to make him bounce, just like he did in the Game Maker version. We got him to rotate, and we've taken some player input and used it, albeit not without a weird outcome that I didn't expect. I'm sure there's a perfectly good reason for this. Perhaps there's a setting where the keyboard, for some reason, registers as a mouse button, and I just don't know it. But it says here, input event mouse button, input event type for mouse button events. Don't see anything about keyboard. Well, I don't know. So so that's that. That's going to do this video. If you're following along, go ahead, add these things to your game, and then tomorrow, what I'd really like to do is wrap this up. I want to get some text so that our player can see the score. And I also want to add a replay button. And if there's time, we can also add the third type of 2D physics body, which is the rigid body. And that's a really interesting and fun one to use. We've used static body, kinematic body, and that's the third type. So I'm going to end this video, hopefully, by fumbling around and acting as if I've never done this before. Hopefully all the sound recorded and everything's going to be great. And this will help you make progress on your Godot version. All right. Thanks for tuning in.